All right, this is the fifth FRQ from the 2012 BC exam, and it's a differential equation FRQ. And then if you look here, you got like, oh, maybe it's a logistic differential equation, or maybe it has something to do with logistic. But this graph is an interesting piece of that, which is why I chose this one. So it says it's talking about baby birds, the rate at which they gain weight. So for part A, they want to know if the bird is gaining weight faster when it's 40 grams or 70 grams. And you can actually make a prediction about which one is faster. Just kidding, never mind. I guess you could make a prediction if you start plugging numbers in your head, but we're going to go ahead and do it on paper. I was thinking about using this graph, but that's not right because you'll see in a second, we don't know if that graph is accurate or not. Okay, so and that's actually a good pointer though. If you see something in the midst of another problem, like if you see this graph in part B, don't use it for part A. It's not meant to be used for part A. So when they give you an FRQ, if they want you to use something for part A or for all of the parts, then they're going to put it up here. Anything that you find later on is not meant to be retroactive. So information from part B is it's not meant for you to go back and do part A. You're not going to take an answer from be able to go back and do part B. You should be able to do the problems in order, and that's kind of a good clue as to whether or not you're using information that's valid or not. So I should not be using this graph for part A because it doesn't show up before part A. All right, so to see if the bird is gaining weight faster when it weighs 40 grams or when it weighs 70 grams, we need to go ahead and take the rate of change of the bird's weight and then go ahead and plug in those different weights. So I'm going to say dB dt at a weight of 40 grams is going to be 1/5 times 100 minus 40, which is 1/5 of 60, which is 12. And the units there are grams for the y coordinate, days for the x, so that's grams per day. And then dB dt at b equals 70 grams is 1/5 times 100 minus 70, which is 1/5 of 30, which is 6 grams per day. And I'm going to say that since dB dt of 40 is greater than dB dt of 70, the bird is gaining weight faster when it weighs 40 grams. Okay. Part B. We have, they want us to find the second derivative, which gives us the concavity, and then they want to use that to explain if this graph is okay or not. So I'm going to go ahead and do the work up here. So I have this I'm going to go ahead and just say is 1/5 times 100 minus 1/5 times b. So that's 20. 20 minus 1/5 b. So when I go ahead and find the second derivative, I've got negative 1/5 times dB dt. So that's negative 1/5 times negative 1/5 100 minus b. Okay, so when I look at this, this means that for a b value that's between that's between 0 and 100, that this is going to be positive. So for a b value that's between 0 and 100, this is going to be positive, which means the graph is concave up. So B of t is concave up. All right, now if I look at this graph, I can see that when, the weight is from 20 up to 60, it's concave up, but there is this whole section of the graph right here that's concave down, and part of that is when the weight is between 60 and 100. So there are values of B on 0, 100 where the graph is concave down, and that's what makes it wrong. All right, and then the last step, they're asking us to take the particular, or the initial condition to find the particular solution, which means we need to separate the differential equation, integrate it, get the plus, solve for C, plug it back in, solve for B of t, do all that stuff. So I'm going to go ahead and write down my differential equation, dB dt, 1/5, 100 minus B. I'm going to go ahead and divide the 100 minus B over. Now, if you watch the other videos I did for these FRQs, every single time I did U substitution for the bottom part, even though you didn't really need it. And on this one, you actually do need it, and that's because the variable has a derivative of -1, which would be really easy to miss otherwise. Of course, you can do it without, but... All right, so what we end up having is -1 over u du. And so we've got negative ln u. So that's negative ln of 100 minus b. Now there's a lot of different places where you could decide to plug in your point. And because this equation is so complex right now, I'm not going to plug it in yet. I'm going to go ahead and divide the negative over. And I'll go ahead and put E on each side. And at this point, I feel a lot better about plugging my point in. You could plug it in before. Your C would work out a little bit differently. Your final answer should look out the same, although it could be in a form that's a little bit different than the answer key. So don't think if you didn't do it this way, you automatically got it wrong. You just have to check and see if they're technically equivalent. So the point that we're plugging in is 0 for T and 20 for B. So that's 80 equals C e to 0, which is just 1. So C equals 80. Don't go back too far. So I've got 100 minus B equals 80. Then I can subtract the 100 over. All right, and then there's my equation. Double check. I was not supposed to plug anything back in, and so I'm good.